All right, welcome to the second part of lesson 3 for unit 1. We are still talking about aquatic biomes, but this is part 2. We're going to focus on freshwater ecosystems. So learning objective is that you'll be able to describe the different freshwater ecosystems as well as the zones of a lake. So for freshwater ecosystems, they may be divided into two broad categories: stationary water, so water that's not really moving, and that's lakes, ponds, and reservoirs, or running water, which is going to be streams and rivers. So for lakes and ponds, we have different zones. Sometimes it's, how far it is from shore, and sometimes it's within the depth. But you do have to know the different zones. So the first one is the littoral zone. And the littoral zone of a lake is the region of a lake with rooted vegetation. So there are plants with roots in that zone. If that is a thing, it's the littoral zone. There are different kinds of plants, so those emergent plants. So these are plants that emerge from the water. So they have leaves that float on or protrude above the water surface. So you can see that plant above the water surface. It's sticking out. And then there's submerged plants. So these plants are fully submerged below the water surface. They do not break through. You may be able to see them if you look down, but they are not actually breaking through the water surface at all. The limnetic zone is the region of a lake with no rooted vegetation. So littoral, we got plants. Limnetic, we have no plants, no rooted plants. There could be some floaters on the top. So these are the two zones. We have the littoral zone here. Right here we have those rooted plants here. Then we have the limnetic zone over here with no rooted plants. There's also the profundal zone. So the profundal zone is that deep zone of the lake. So we have like crustaceans and things down there depending on where this lake pond thing is. All right, so freshwater ecosystems. The productivity of a lake is determined by many factors. So if it is really cold, then if you remember back to chemistry, heat is a sort of energy and it helps chemical reactions happen more frequently, faster, all of those things. So if we have cold temperatures, those reactions are happening at a lower rate, which means it's also going to affect photosynthesis. So cold temperatures means lower rates of photosynthesis. Shallow water allows for more photosynthesis. If the water is shallow, that means the sun's light can penetrate the water a lot easier and more of it's getting to the plants. Whereas if it's really deep, then that sunlight has to go through a lot more water to get to the plants. So we're going to have less photosynthesis because more of that sunlight is going to be reflected back. And then erosion from the land increases nutrient levels. So sometimes this is good, sometimes this is not so great. And then dissolved oxygen, so fish need oxygen. Plants create oxygen underwater. They also use oxygen. But we get dissolved oxygen in lakes through wave action. So like the waves create bubbles, which dissolves oxygen a little bit more into the water, and also photosynthesis being released from those plants. Determines the kinds of organisms that can inhabit the lake. Lots of oxygen is going to support different organisms than not so much oxygen. Okay, so there are different types of lakes and ponds just as a whole. So the first one up top here is going to be oligotrophic. So oligotrophic lakes are deep, cooled, and nutrient poor. Eutrophic lakes down here at the bottom, skipping to the end, they are shallow, warm, and nutrient rich. So oligotrophic lakes are really clean, clear. You want to swim in them. You can see the bottom, beautiful. Eutrophic, we have a lot of plant growth. We usually have some algae, a lot more living things in there. There's a lot of nutrients and life happening. And then biochemical oxygen demand, or BOD, that's going to be the amount of oxygen used by decomposers to break down a specific amount of organic matter. So it's the oxygen demand by decomposers that's needed to break down organic matter. And the more organic matter we have to break down, the higher that oxygen demand is going to be. All right, for streams and rivers, even though most streams are shallow, you can see the bottom, you can touch the bottom standing up, it's difficult for a lot of photosynthetic organisms to accumulate nutrients necessary for growth because no nutrients really hanging out. That water is constantly rushing and moving, so it's taking a lot of those nutrients with it. Most clear streams are not very productive. There's not a lot of photosynthesis happening. And most debris is input from terrestrial sources. So tree limbs falling, animals walking through and taking some of that debris with them. And then, because we have fancy words for everything, we have periphyton, and that's the collection of algae, animals, and fungi attached to rocks and other objects on the bottom. So here we have some of that algae on this rock down here. That would be periphyton. Continuing with streams and rivers, swamps fall into this realm because sometimes that water does move a bit. So swamps are wetlands containing trees that are able to live in environments that are permanently flooded, or at least flooded most of the year. So it's not necessarily always flooded, but there's a lot of water most of the year. And then marshes are wetlands dominated by grasses and reeds. So there is a difference between a swamp and a marsh. Swamps have trees, marshes have grasses and reeds. Many swamps and marshes are successional states that eventually become totally terrestrial communities. We will talk about succession, but it basically is going from an oligotrophic, a really clear lake, clear stream, clear whatever, and then becoming eutrophic, where we have a lot more nutrients, plants, animals, and all of that. And eventually, over time, more and more sediment and nutrients build up in that lake, and the space for water becomes less and less and less, and it will just become a swamp or marsh, and then no longer considered a water ecosystem, because it'll be filled with so much sediment that it just becomes dirt or soil. So this is what a swamp would look like, lots of trees, and then this would be a marsh. Not so many trees, lots of grasses. So human impact. Most freshwater ecosystems have been heavily affected by human activity. Any activity that takes place on land ultimately affects freshwater resources because of runoff from the land. So us driving cars, even on the street over here, that it's going to rain, the rain is going to take all of the chemicals or sediment that we leave on the road, and everything eventually will end up in some sort of water ecosystem. That includes agricultural runoff, sewage, sediment, and trash that all eventually can find their way into streams and lakes. All right, that's the end for this lesson, the end for lesson 3 as a whole. Please let me know if you have any questions, and I will see you in the next one.